afternoon to all. Respected Director IITM and senior scientists present here. Also my colleagues, students. I would like to thank our committee, IITM and MOES for this prestigious award. And I wanted to thank Dr. Vanashilan for his consistent guidance for last 2 decades. We have been working together for almost 20 years. And I should thank Dr. Anant Parikh and Professor Shamping Z for their close collaboration for more than 1 decade. And many co-authors, actually, they have contributed a lot. And without students' help, I think this work is not possible. So I should thank them too. And I am very honored to have this particular award. So I'm going to talk about Indo-Western Pacific climate variability and impacts on Indian summer monsoon. So if you see that picture, you would see red colors. That means you have temperature more than 28 degrees Celsius for the tropical Indian Ocean and Western Pacific. We call it as a Indo-Western Pacific. So this is very important region because the convection over this region is high. When you have strong convection it can communicate to the other parts of the globe. So therefore we call it as a heat engine of the globe. And at the same time in the ocean, you do see a shallow thermocline in some parts of tropical Indian Ocean and parts of Western Pacific. Their air-sea interactions are very strong. And in particular, the Indo-Western Pacific climate dominated by 4 major systems, that is El Nino Southern Oscillation, Asian Australian monsoon, and Indian Ocean dipole and Indian Ocean basin-wide warming. Any change, if you look at the SST, convection or circulation, or interplay between among all these systems can trigger anomalous features of circulation, and it can influence the South Asian monsoon or Indian summer monsoon. So our journey begins around 2005 with Dr. Vanashilan. So we were the first, one of those first papers published on basin-wide warming in 2007. So this paper says that when you have El Nino and IOD co-occur, basin-wide warming is stronger. You can see that during the peak phase of El Nino, this is DJ of season, that means boreal winter season. You have strong warming over the equatorial Pacific. And then when you have that vapor circulation induced subsidence over the tropical Indian Ocean, and because of that you do have short wave radiation high and latent heat released to the atmosphere is low, and therefore you have warming most parts of the tropical Indian Ocean. That you can see this is strong in the co-occurrence years, and El Nino years also you do see basin-wide warming. And this warming persists to the next season. At that point you can see that the warming is very strong in the southwest tropical Indian Ocean. So this warming in the southwest tropical Indian Ocean is not because of heat fluxes, that is because of ocean dynamics. So in the subsequent paper in 2019, we came up with this interesting result that subsurface anomalies are trapped within the the thermocline region over the southern tropical Indian Ocean. This plot is showing at 10 degrees south. You can see with time the anomalies are propagating from east to the west and upward. So this westward and upward propagation of temperature anomalies associated with Rossby waves and the sloping of thermocline the first time reported. And this warm anomalies propagating from the east to west help to sustain the southwest tropical Indian Ocean warming, and that is more important because there is strong air-sea, it enhances the strong air-sea interactions over that region. Apart from this, and we have also reported for the first time barrier layers. You can see that barrier layer propagating westward along with the Rossby waves, and this barrier layer shields the cooling from below and helps to sustain warming over southwest tropical Indian Ocean, and that gives a convection there. So the contour shows the precipitation. So when you have strong precipitation, again fresh water is added to that and the barrier layer enhances. So there is a positive feedback. So this robust westward propagation of BL thickness is reported for the first time in 2019 based on the Argo data. That is the Argo data was also gridded by OI method in our lab. And these results are very well valid, and we have proved with the syntax model experiments. So why I would say this is an important result? Because following our study, Bruce et al. Showed that this BL variability is very important for triggering cyclones over the southwest tropical Indian Ocean. This is the region you can see. This particular event of 2006-07 we have reported in our paper, and then later Bruce et al. Confirmed all these cyclones. Apart from that, when you have strong warming over this region, it can hold ITCZ there, and therefore it can cause some delay in the monsoon onset according to Annamalai et al. And we do know that this is the region of MJOs generating, so this is always very important to have these barrier layers there. Therefore, this the work on the southwest TIO oceanic barrier layer is important finding. As I indicated, you can see that there is a basin-wide warming in subsequent months of this DJF or peak phase of El Nino in MAM+1. That means spring after decay phase of El Nino is very strong here. And then when you move on to the next season, you have summer. So in summer, the persistence of tropical Indian Ocean basin-wide warming is seen, but at the same time, you don't have El Nino there. So you can see the other plot here. The dashed line represents the El Nino, and El Nino peaks in DJF, and at the same time, you would see that tropical Indian Ocean is also warming, and it warms as the El Nino is gone for, in the next summer. So you do see that tropical Indian Ocean warming in different regions is sustaining. In the presence of El Nino, we know that the tropical Indian Ocean warming is kind of passive. On the interannual time scale, if you don't have El Nino, but you do have this basin-wide warming, so is it passive or active? So that was important question. And the impact of these anomalies are actually have been neglected for a long time on the basis of El Nino impact. So apart from the basin-wide warming, what you see here, you do see anticyclonic circulation over the northwest Pacific. So that is started or began in DJF or at the peak phase of El Nino. So when you have El Nino, you do see that anticyclonic circulation over the northwest Pacific, and in the subsequent season, the anticyclonic circulation is also persisting, and the cooling is also seen over the western North Pacific. And that cooling is disappeared by next season, DJF. You do see only two components here. One is the tropical Indian Ocean warming and western North Pacific anticyclone. And these two are like very important components. There is a strong feedback between them. So the feedback can be explained with Indo-Western Pacific capacitor mode. So basically, when you have strong El Nino here, due to the Mestuno gill pattern, you do generate cyclonic circulation just northwest of that. And then on the northern flank of cyclonic circulation, you do see there are anomalous northeasterlies overlapping with mean northeasterlies, enhances the wind there, and then latent heat flux release to the atmosphere causes weakening of SSTs, or you do see negative anomalies over that region. So negative SST anomalies generates westward the anticyclonic circulation over the western North Pacific, and the same time the Rashmi waves are triggered due to the anticyclonic circulation over the southeast equatorial Indian Ocean at the peak phase of El Nino. And as you come to next season, the El Nino is slowly weakening and the anticyclone is still persisting, that is maintained by this particular cooling, that's Northwest Pacific cooling. And this southern flank of anticyclone, you can see that easterlies are induced into tropical Indian Ocean, and then they become northeasterlies there. And as you know that this Rashmi, downwelling Rashmi wave propagates to the southwest tropical Indian Ocean, maintains the warming there. So when you have warming there, there is a convergence. So you do see a she-shaped winds here. This is nothing but asymmetric mode of winds in the spring season. And as you move on to the next summer, so the basin-wide warming is clear because you have easterlies there. So they are against the southwesterlies in the summer, and because of that weak southwesterlies, latent heat flux release to the atmosphere is weak. Therefore, your SST is warmer in the northern part of Indian Ocean. In the southern part, because of ocean dynamics, you do have already ocean warming. So entire tropical Indian Ocean is warmer, as you can see here. And when you have this tropical Indian Ocean warmer, you do have this strong convergence there and convection there. In the convection, in the troposphere, this strong convection can produce a latent heat flux release, and therefore you have tropospheric warming in the troposphere. So the tropospheric warming generally moves towards the east as a Kelvin wave at the equator, and this is a Kelvin wave trapped at the equator. So this Kelvin waves moves warm temperatures to the western Pacific, and the warm layer lowers the SLP at the surface and drags the easterlies to northeasterlies at the equator. As you go up in the half the equator, the easterlies becomes like spinning more as due to the Ekman divergence. In the free troposphere, this anticyclone intensifies. So this Ekman divergence mechanism with the Kelvin wave induced is coupling this both Northwest Pacific and Indian Ocean. So this interbasin interaction is nothing but Indo-Western Pacific capacitor effect. And when you see one more point here is the anticyclonic circulation, cyclonic circulation and low here. This structure is nothing but PJ pattern, Pacific Japan pattern, and that is also very important. So as we have discussed, the Pacific Japan pattern can be seen in 850 HPA wind with like negative, positive and negative and many other variables. So even without tropical Indian Ocean warming, this Pacific Japan pattern can be seen, and that can impact the summer monsoon. And so why we call this particular mechanism as a capacitor effect, that is important to know. So you can consider ENSO as a battery in the circuit. So this ENSO charges the capacitor, that means tropical Indian Ocean, and once the battery is discharged, that means ENSO is gone in the next summer, so the capacitor starts reacting. So, and this capacitor, for example, Indian Ocean warming is maintaining Northwest Pacific anticyclone. So this is how tropical Indian Ocean works. Therefore, this is called the Indo-Western capacitor effect. But how it matters for the Indian summer monsoon? Here we can see what you see here. Here is the IPOC pattern obtained by SVD analysis. When you consider the tropical Indian Ocean warming and vorticity over the Northwestern Pacific, and you perform the SVD analysis and you do get this pattern. So this IPOC pattern induces tripole-like pattern over the Indian summer monsoon region. You can see high rainfall over the northeast India and southern peninsular India, and low rainfall over the monsoon trough region. So this tripole pattern is induced by a IPOC mode. So it is clear that the regional rainfall patterns are strongly influenced by IPOC mode. And what are the mechanisms that links this IPOC and the monsoon rainfall is that when you have strong subsidence or means low precipitation over this region, so westward propagating atmospheric cold Rossby from western North Pacific propagates to the monsoon trough region, and because of that you do have a divergence, moisture divergence over that region. So because of that you do have a negative rainfall over the monsoon trough region. In the south, because of convergence of moisture winds from the Arabian Sea and from northwest Pacific, the high rainfall is increasing over that region. In the northeast region, rainfall is increasing because you have southerlies from the anticyclone, that moisture laden winds interact with the orography. You have a strong rainfall in the northeast region. So you can see the mechanism explained here in this particular schematic. So the Kelvin wave is moving from the tropical Indian Ocean region when it is warmer, and that is enhancing the anticyclonic circulation, and that is inducing the easterlies, and it is again warming the tropical Indian Ocean, and again it is feeding back. So there is a strong feedback between the anticyclonic circulation or PJ pattern and tropical Indian Ocean. So this is a useful component. And without tropical Indian Ocean, this PJ can induce some impacts onto the Indian summer monsoon, and this PJ can sustain without tropical Indian Ocean. So if you have like strong convection over this region or subsidence, it can produce the stationary Rossby wave and PJ can be formed. Or if the Mayu ran, like if this rainfall is stronger over that region, then it can form a PJ pattern. Apart from this, mid-latitude SRP pattern or Silk Road pattern can cause changes in the westerly jet that can induce PJ pattern. So PJ pattern alone also influence the Indian monsoon rainfall. So now the why these like IPOC impact we have seen on the Indian summer monsoon, why it is important? Because it is not only influencing the seasonal rainfall, also sub-seasonal rainfall. For example, if you see here, July rainfall was deficient in the monsoon trough region in 2020. And you can also see the IPOC pattern is so strong in that particular month. So here the two forces are mainly responsible to sustain this PJ pattern. One is from the mid-latitude, that is Silk Road pattern, another is from the tropical Indian Ocean warmings. These two together produce this tripole pattern. This, if you might have heard that in July and June there were devastating floods over the northeast India and high rainfall over the southern parts of India. So these are all because of the IPOC mode or PJ pattern. So it has strong impact on the sub-seasonal monsoon rainfall as well. So try to see that models whether they can predict, but unfortunately you see that the lines are representing CFS with different initial conditions, could not predict all India summer monsoon rainfall variations. Even NMME models also not able to produce July deficient rainfall or high rainfall over the northeast India, etc. So models do have limitations to predict IPOC related rainfall anomalies. Not only just 2020, if you look at 2021 August, the PJ pattern is very strong. At the same time, you don't have a tropical Indian Ocean warming, and at the same time you can see that there is a increasing rainfall over the northeast India, and this is because of the PJ pattern. And this particular year, this year June, we know that floods are happened, like high rainfall over the northeast India. and that is also particularly because of anomalous anticyclone over the Northwest Pacific, and there is a decreased rainfall over some parts of monsoon trough region. So it looks like the impact of this PJ or IPOC mode seems to be increasing these days. So the main reason for the flooding over the Northeast India due to this anticyclone can be explained from here. So we have shown that these strong southerlies associated with this anticyclone taking moisture to the Northeast India because of orographic lifting, the floods just commonly occur and the rainfall can persist for a long time. This kind of events that happened in 2020 early monsoon can increase in the future according to the CMIP6 projections. So this is another important result, and not only subseasonal rainfall, so IPOC can modulate the ISO phase as well. It is not just only rainfall. So decaying spring, for example, when the El Nino is decaying, so you have spring as well as summer. So during the spring, the heat wave days are increasing. That means we need to consider a decay phase of El Nino seriously, not just the developing phase. Not only these heat waves, and you see discomfort index in that particular spring decay phase of El Nino spring is high, so it is that means it has a straight away influencing the human health. And moreover, we know that when you have a developing El Nino, so number of depressions generally are less. But we found that recently that is not the case. So in the decay summers of El Nino, number of depressions are much lower than the developing summers. For example, 2010 is the decay summer, you don't have even a single depression. So this is our results obtained here are very important and has a lot of applications onto seasonal prediction as well as on ISO scale. So how predictable is this IPOC? So this is predictable. You can see the IPOC predicted from May ICs, anticyclone and tropical Indian Ocean basin-wide warming are well predicted in 1 month ahead. That means from May initial conditions in these ensemble models. However, that impact of this IPOC on summer monsoon is not well predicted. So there is a problem. That means even in the February initial conditions, IPOC is well predicted, but associated rainfall over the Indian summer monsoon is not well predicted. Of course, in some models, the El Nino is persisting longer than what it should be. Therefore, IPOC is not well organized. Therefore, the associated rainfall patterns are not well predicted in the Indian summer monsoon region. But there is a basin-wide warming and there is anticyclonic circulation. These two components are seen even in the spring season, and using that information we have developed a regression model that can actually predict the regional rainfall such as rainfall over the eastern parts of monsoon trough region, and we have somewhere like southern parts of India and northeast India rainfall can be predicted at least one season ahead using this model developed. So Northwest Pacific anticyclone is not only important for the decaying phase of El Nino but also developing phase of El Nino. So here what you see, there is a regional patterns even during the developing phase of El Nino summers. This rainfall is high in the central North India and southern peninsular India, and when you see that these rainfall patterns are consistently having strong relationship with El Nino. When you consider entire India as a one particular point, then what you see is there is weakening of El Nino monsoon teleconnections. But when you consider separately these regions, the ENSO monsoon teleconnections are not weakening with time. So this is a little bit contradicting to what has been reported earlier. And these regional patterns are highly influenced different epochs because of these changes in anticyclonic circulation in the Northwest Pacific. Not only that, even El Nino Modoki can induce this sort of cyclonic circulation because of gill pattern, so that can reach to the Indian monsoon region, and there is an increase of rainfall in the monsoon trough region, decreasing rainfall in the south. So both El Nino developing as well as decay phase, Western North Pacific playing a very important role. So this is just one example to show that there are multi-teleconnections operating in a particular year. So it can be more than one mode that can operate onto the rainfall. For example, in August, you have PJ pattern and you have Atlantic Nino and negative IOD like pattern that can operate simultaneously. And in September, increased rainfall is because of this anomalous anticyclonic circulation just northwest of India. That is basically due to the this SRP pattern or Silk Road pattern or Rossby wave like pattern from the mid latitudes. That means mid latitude teleconnections are much stronger. Therefore, it is not by one particular process the rainfall is modulated. There are many modes that can influence the monsoon. So keeping this in our mind, so we have proposed a book and came up with a publication which is called entitled Indian Summer Monsoon Variability and El Nino Teleconnections and Beyond. So this book is talking about all possible monsoon teleconnections. These are different chapters that may be useful for the students. Talking about climate change and Indian Ocean, Atlantic Ocean impacts onto the monsoon and mid-latitudes teleconnections as well. So these all are summarized in this particular diagram. You can see that ISM is influenced by many factors: canonical El Nino, Modoki, decay phase, IOD, Equino and Atlantic Nino, Eurasian snow, PJ and many others. So on the decadal time scale, PDO, AMO, all these are discussed in this book. So other than that, contributed in various subjects like Indian Ocean climate variability and coupled modal biases. So this work expands the window of ISM predictability from El Nino growing summer to include the post El Nino summer in addition. So what we say is the pathway from the Northwestern Pacific cyclonic or anticyclonic circulation to connect the ENSO is the new thing that we feel that has a strong impacts. And this work, especially IPOC impacts, are reflected in many ways, like in springtime heat waves and depressions in the summer, etc. And overall, this work led to improved understanding of Indian Ocean climate and Indian summer monsoon variability and predictability. Thank you.
Can I ask a question, please?
Yes, sir.
Can I ask a
Yeah, please.
Yeah. See, it's well known that the El Nino is the season or the epoch when the rainfall is less for India. Why did not you analyze La Nina when the rainfall is higher? And also, I am saying La Nina because for the first time in history, for the last 3 years are continuously La Nina. It never happened earlier. First time it happened, and this is well known. This extreme La Nina apparently caused the floods in Pakistan and probably the extreme droughts in East Africa. I am saying your work is very nice, congratulations. What I am saying is, it would have been more profitable to talk about this, the what you call phenomenon which caused more rainfall or higher rainfall or Indian monsoon season. That is the La Nina, is it not? So, and also this particular last 3 years continuous La Nina may be what you call a response of climate warming or something like that. So what are your comments?
So, if you talk about prolonged ENSO events, particularly La Nina, it will have different impacts on the monsoon. We have done work, maybe I have not presented here. So, we see that developing El Nino first year will have a different impact, but second year will have a different impact, and third year will have a different impacts. It's not that all La Ninas are going to give a enhanced rainfall over India. For example, even this particular year you see that the rainfall is like it is regionally, you have to look at the regional rainfall patterns. It is not that just area like whole India as a whole, you cannot see that. For example, this year rainfall is high over the southern parts of India and lower like Bihar and Uttar Pradesh, just foothills of Himalaya. So we have studied all these La Nina related teleconnections.
No, I know that there are clear years of higher or lower rainfall which are not associated with the ENSO. I know that. But
Yeah.
what I am saying is, just as you analyze El Nino, certainly there are El Ninos in which these things will not happen. And also, as you said, all La Ninas not high rainfall. By the same token, all El Ninos are also not years of drought.
Exactly.
So there is something complementary.
Yes.
What I am suggesting is the very, very unusual 3 continuous years of La Nina is something spectacular, something very, very different, and it caused very high rainfall in the southwest monsoon season, because after all, Pakistan also is a part of South Asian monsoon. So Pakistan, although it may be a different country from a climate, from a meteorological point of view, is a part of South Asian monsoon. And this particular threat of 2022 is something very, very unusual, and the droughts and almost like famine in East Africa, these seem to be related, but these are something very, very different. It's interesting, as you said, Doctor, you answered to me, all El Ninos or all La Ninas are typically higher or lower. I know that. What I am saying is, if you say for the La Nina, it's not always higher. I will say the El Ninos are also all not for lower rainfall, by the same token. So what I am saying is, it will be interesting maybe for the next, your study is definitely very interesting, important. I am saying for the next step, maybe you analyze La Nina, the spectacular 3-year La Nina.
Yeah, thank you. Thank you for suggestion. We will discuss later. Yeah, thank you.